Hello students, welcome to Vetri Neet Gateway. So I am your physics faculty Ravi Kumar. So already we have saw the class 9th chapter 7th motion. We have saw many videos, 7 videos. Yes or no? We have made 7 videos. Okay. So this is the last part video. Okay. The topic is uniform circular motion. Okay. This is going to be the last part video. So we have completely thoroughly see the motion chapter in the last 7 videos. So if you didn't see the last 7 videos, the videos description, the videos links will be provided in the description. So kindly use that. Okay. After seeing that, you can see the uniform circular motion. Okay. Next. So what is uniform circular motion? What is uniform circular motion? So uniform circular motion in acronym we can call it as UCM. Shortly we can call it as a UCM. It refers to the motion of an object traveling at a constant speed, not a constant velocity, it's a constant speed along a circular path. So when an object travels in a, so consider the circle, the radius of the circle is r. So this object is traveling in the constant speed, not constant velocity. I will tell you why it is not constant velocity. So it is traveling in a constant speed in a circular path, means then the object is undergoing what? Uniform circular motion. That object is undergoing what? Uniform circular motion. Okay. So the velocity is continuously changing. How it changes? Because velocity is what quantity? A vector quantity. Velocity is a vector quantity. Yes. Velocity is a vector quantity. Velocity is a vector quantity. It not only talks you about the magnitude but also the direction. See here, the magnitude, the speed doesn't changes. So here the velocity is this direction. When the body comes here, the velocity is in this direction. When the body comes here, the velocity becomes in this direction. See, the velocity keeps on changing because there is no change in magnitude but change in direction. So the change in velocity occurs due to whom? Change in direction. This change in direction will produce acceleration. The biggest question is, the acceleration means what? It will increasing the speed or decreasing the speed. If you increase the speed, acceleration produce. If you decrease the speed, acceleration also produce, which is deceleration. If you change the direction, whether acceleration produce? Yes. So the change in velocity will be in 3 cases. Okay. Let me see that. The change in velocity will occurs in 3 cases. One is what? Increase in velocity. Keep this in mind. We have already saw this, increase in velocity. Next is what? Increase in velocity means what? We can say increase in speed and increase in velocity. Okay. Next is decrease in speed. So if the speed increases, it will change. If the speed decreases, it also leads to change. And velocity is a vector quantity, not only talking about the magnitude but also a direction. So change in direction. Change in direction. If increase in speed means acceleration is equal to positive. If decrease in speed means acceleration is equal to negative. So if change in direction, what happens to the acceleration? That's the question here. So here the acceleration is used only to change the velocity. How it is changing the velocity? By changing the direction. Okay. So listen carefully. An object is undergoing consider this is the object. So this is the radius of the circle. Okay. The object is moving in a circular path. So at this point, what is the acceleration? Let me use the different color here. Okay. The acceleration is draw a tangent. This is the velocity. This is the velocity. So at this point the velocity is tangent. Okay. Next at here and at also here and at here. Okay. See here, at this point what is the acceleration? The velocity is in this direction. Draw a tangent. At this point what is the velocity? The velocity is in this direction. And this point the velocity is in this direction. At every point the velocity, the direction of the velocity is changing. The direction of the velocity is changing. Who makes the change? Who making the change? The acceleration. The acceleration is acting towards the center. Let me draw one more time. Who is making the change? The change is due to acceleration. This acceleration is called as centripetal acceleration. What acceleration? Centripetal acceleration. Okay, so the centripetal acceleration changes the velocity. How it changes the velocity? By changing the direction. By changing the direction. So in uniform circular motion, change in velocity is due to change in direction. But its speed is constant. What is the speed? Speed means the body is revolving with 5 meter per second. At all the points, its speed was 5 meter per second only, or it can be 10. The speed is, the number value is constant. For example, 5 meter per second, it revolving 5 meter, or 10 or 20. But speed is constant, but its velocity is not constant. At every point, its velocity is changing. So that produces acceleration. That acceleration is called as what? AC, which means centripetal acceleration. Okay, so speed remains constant. Velocity changes due to direction change, vector quantity. Okay, what is centripetal acceleration? What is centripetal acceleration? Always directed towards the center of the circle. Always directed to the center. So here the acceleration will be directed toward like this, AC. Here also directed towards the center, AC, centripetal acceleration. Here also AC. Okay, so you should keep this in mind. You should keep this in mind. Okay, AC. Okay, this is the uniform circular motion. So some examples of uniform circular motion: satelliting revolving around the earth, satellite orbiting the earth. So the moon also orbiting the earth, right? That's are all the best examples for uniform circular motion. Car turning in a circular track. When the car approaches a circular track, it will, okay. Electrons orbiting the nucleus. So this is the nucleus and the electron is revolving. Electron is revolving around the nucleus, right? That's the best example for uniform circular motion. So a stone tied to the string and whirled in the circle. So if you tie the stone and your starts to rotate, means the stone will rotate in a uniform circular motion. Okay, these are the best examples for uniform. Best examples are satellite and the electron orbit around the nucleus. Okay, let me see the problems based on this. An artificial satellite is moving in a circular orbit of radius. How much kilometer? So artificial satellite is moving in the radius of circular orbit of radius 42250 kilometer. Okay, consider here is the satellite. Okay, consider this is the satellite. Calculate its speed if it takes 24 hours to revolve around the earth. So consider here is the earth. So it takes how much hours? 24 hours. T is equal to 24 hours. So calculate speed. Speed is equal to what? Speed is equal to distance by time. Distance by time. What's the distance here? We know the time here. What's the distance? Distance is equal to, so it moving around one complete circle. So it is the circumference of the circle, 2 pi r. So 2 into pi is how much? 22 by 7 into 42,250. 2 pi r. Okay. So how much times? Yes, students, we can continue further. See here, this is some more not difficult, some more big numbers, right? So I am using calculator here. So see here, so I am going to divide 42,250 divided by 7. It gives you 2 into 22 into, if you divide 42,250 by 7 means it gives you 6,35.71. Okay, so I am going to multiply this, all this. So 6035.71 multiply with 2 into 22 is 44. So if you multiply with 44 means you will get 265,571. Okay, so kilometer. So distance is how much? This much. They are asking to find the speed. So speed is equal to distance by time, right? So distance is 26,551. Time is how much? 24. Okay. So divided by 24, which is equal to 11,065 km per hour. This is the answer. Speed is equal to how much? So the satellite revolves around, we should give a knot to convert in the meter per second. These are not the small quantities, they are big quantities, right? So kilometer per hour is the best way to represent the speed here. So this is equal to 11,065 km per hour. So kindly note this. Next question. State which of the following situations are possible and give me an example for each of this. An object with a constant acceleration but with zero velocity. An object with a constant acceleration but with zero velocity. Whether it is possible? Yes. Whether it is possible? It having constant acceleration but velocity is zero. See here, when I start the bike, what will happen? Okay, so without leaving the clutch, so without putting in the gear, if you accelerate means whether the bike moves, doesn't move. Okay, so after putting the gear, after leaving the clutch only, the bike starts to move. Yes or no? If you know the little bit about the knowledge about the gear bike means, you can definitely tell that. So the bike is ready to move, but its velocity is zero, but we are accelerating. The acceleration is not zero here. So the acceleration is not zero. Okay. So it's possible. It is possible. So we can say the velocity is zero, acceleration is equal to constant. Yes, possible. For a bike example, motor vehicles. So we can say motor vehicles are the best examples. Okay. So an object moving with acceleration but with uniform speed. Okay. An object moving with uniform acceleration but with uniform speed. Whether it is possible? Yes. Where it is possible? It is possible in uniform circular motion. What motion? Uniform circular motion. Yes, I have told you, right? Uniform circular motion. What is uniform circular motion? An object undergoes in a circular path with uniform speed, with a constant speed. The speed is equal, consider the speed is equal to 5 meter per second. But its velocity is changing. At every point, its velocity is changing. At every point, its velocity is changing. At every point, its velocity is changing. The direction of the velocity changes, but speed remains 5. So the change in direction leads to what? Change in velocity, because velocity is a vector quantity. Velocity is a vector. This change in acceleration produces what? Acceleration. What acceleration in uniform circular motion? This acceleration is called as centripetal acceleration. Centripetal acceleration. Okay. Centripetal acceleration. Okay. Whether this acceleration is uniform? Not at all. Acceleration is a vector quantity. See here, acceleration is same only, but acceleration always acted towards the center. We have already saw this. Okay. So acceleration always acted towards the direction, so towards the center. At every point, this direction is changing, right? So this acceleration is not constant. Acceleration is not constant. Okay, because direction is changing. So centripetal acceleration is not a constant acceleration. Okay. So an object is moving with a certain direction with an acceleration in the perpendicular direction. So object is moving in a certain direction, whether its acceleration is perpendicular, whether it is possible? Yes, possible. Same uniform circular motion. All question based on uniform circular motion only. See here. So in uniform circular motion, consider this is the center point O and here is the object. So at this point, what is the velocity? Where is the velocity? Draw a tangent. I have already told you, draw a tangent. This is the velocity. Where it is the acceleration? Acceleration acted towards the center. So what angle it is making? So in uniform circular motion, the angle between velocity and acceleration, centripetal acceleration is 90 degree. So we can see in here also. Listen here. Where is the velocity? It is tangent, draw a tangent. So acceleration is always acting towards the center, centripetal. The angle making is 90 degree. Okay. So at every point, the velocity, every point in uniform circular motion, the angle between velocity and centripetal acceleration is how much? Is 90 degree. That is what the question is asked. So it's perpendicular, right? Perpendicular means what? 90 degree. Can you able to understand? We have saw the complete chapter on motion. Okay, we have done 8 videos, 8 part. We have divided the motion chapter into 8 parts. So kindly go through every part. If you can't able to understand the video means kindly repeat it one more time. So definitely you will be gain some advantages on the topic motion. Okay, so kindly make use of it. So we have provided the playlist in the channel. Go and see the channel playlist. There will be the class 9 chapter 7 motion playlist. Kindly see all the videos. So after seeing all the videos, you will gain a wonderful knowledge about the motion. Okay, thank you.